Hi, this is Bits and Pieces, the official podcast of Component Supply. I'm Kristin.
And I'm Mark.
And today we're going to be talking about mesh.
Again.
This is the segment, There's No Such Thing as a Stupid Question. And so we are going to be answering questions that we've received from you all through our messaging platform over the past several years. They do kind of take a similar theme. We get asked a lot of the same kind of question. And so we're continually putting resources on the Resource Center for you to review. And so we'll mention some of those throughout the podcast. And if I'm feeling techie, we'll pop them up here in the middle of the podcast. But we're just going to run through. I feel like I should ask you all the questions. You should answer them all. Just to make sure you're staying in touch with your customer base.
Oh, okay. This is really for me.
It's training, actually.
Okay.
Yeah, that's what this is. This is training. We can talk through kind of what they're asking for.
Okay.
So one of the questions that we get asked frequently is, like, what are the differences between polypropylene mesh, which we do not supply, nylon mesh, and polyester mesh. So at a really high level, I will correct you if you're wrong.
Wow.
I'm just kidding. But when you're thinking about the differences, when you're just trying to advise a customer.
Yes. So
what would you say? How do you distinguish between those?
So let's start at the bottom instead of the top. So nylon is kind of just the general purpose woven mesh product. It can be used in anything from filtration or separation. In lots of applications, the minute you move outside of something that like a basic solution or water and then move into something acidic, you need to jump kind of to the polyester. And we jump to polyester really because in the world of woven mesh, those are the two materials that are used the most. Polyester is more used in the world than nylon is. We don't really see that here in our industry, but if you look at what's used in the screen printing industry, which uses a ton, just a massive amount of polyester mesh or woven mesh, polyester's the winner. Then from there, now you go to all these other kind of very unique applications, something that requires a particular heat, or it's a specific solution or gas. So now you need something that's either acidic, has some form of, maybe it is a medical application, and so you find mesh in nylon, polyester, polypropylene, but again, that's a very small offering that's produced in the world, and then there is even PTFE, but that's even produced less in the world. Yeah. And then outside of that, you can jump over to stainless. I don't know if we're dealing with that or not, but there is a stainless steel aspect. But those are kind of the major high-level differences.
Stainless is, we don't actually get as many questions on it. I think people know when they're going to use a stainless steel mesh, it's like a very corrosion resistance application.
Well, we've got it right here.
Yes.
There's, the acoustics use, stainless steel. The acoustics industry, use it for, or use nylon and polyester as well, depending on what they're trying to do or what the application is.
Yeah. I would say, just to add to what you're saying, we don't deal a lot with polypropylene other than just to do a comparison between nylon and polyester. So we have a resource on the website that compares the three and their properties, how they react to different impacts. And so, but generally for our customers, they're comparing nylon and polyester, and you said our industry. For the sake of the podcast, we're talking about medical device, but we really consider ourselves the resource for R&D. So we have this kind of umbrella that's R&D for a lot of other industries as well. So when we're dealing with the distinguishing between nylon and polyester, I would say it's true. Nylon seems to be the more favored in a lot of the medical device applications. But we service a lot of aquaculture applications as well. And so a main point of concern for that industry would be exposure to salt water, in which case polyester tends to be the better choice. It's not going to last forever or as long as a stainless option, but it provides a flexibility that maybe stainless is a little bit less flexible. That sometimes is a point of concern. Is like pulling. You're like trying to pull it to reach something.
You see, if you go look at the aquaculture, you've got these like plankton nets, and they are made out of polyester.
Yeah.
Those, nylon has a tendency to absorb water and get brittle, and over time,
gummy and stretchy.
And polyester doesn't have that characteristic. And so if it's an application that's exposed to water for a long time in aquaculture, yes, they will tend to lean towards polyester.
Yeah.
But what we see a lot too is so many of these applications, the exposures to whatever they're doing is so temporary that they just use nylon because you can look at all the specifications, you can look at all the features and the benefits at the end of the day. It's not going to be in whatever the application. It's not such a long-term application. You can't use nylon, and then you were throwing it away anyway.
Right. It's more like a disposable application. Right. That's the way to go. You have a lot. It seems like you have more options for nylon than you do for polyester
Always.
from a size perspective. So, if your sizing is really particular, because in mesh we're talking about microns. So really, the differences between the sizes for some applications it doesn't matter. Like it's going to capture. So aquaculture, some of those more industrial kinds of applications, where the size isn't there. There's more flexibility. But then you get into more of the medical device, and the difference between just a few microns. It's hard for me to wrap my mind around that, but it's important. And so there are more size options for the nylon, particularly what we stock. Okay, we get a lot of questions about flexibility, and they're usually very broad, so we have to kind of work through that. But a lot of times we'll get this question of how flexible, which is such a hard question to answer. How flexible is the nylon and polyester filter screen? Like, it's literally a question. And of course, that's going to depend on sizing. It's going to depend
more than material, for sure.
Like, are you talking about you want it to stretch, or do you want it to, form? So how would you answer that question, maybe? And how can we help our customers to ask a better question?
Yeah, I think first, if you were to ask that, our customer service team's really great. They're going to trying to figure out what you're talking about. You're talking about if I have a sheet of this stuff, I fold it. Is that the flexibility you're talking about? Are you talking about like, can I kind of pull it back and forth? What is? Let's define flexible and make sure we understand that we're talking about the same thing. From there, you've got two plastic materials that are woven together, and the next big thing is it's not so much a material issue as if I've got these all have individual threads. They're woven together. So if I have threads that are 15 thousandths in diameter or so, versus the same material, but the thread is now 80 thousandths. One, obviously, the one that has thicker threads is just not going to be as flexible. It's just not going to.
Right.
And
it's going to feel super rigid.
Right.
Yeah, you think about some of our bigger meshes, they feel almost like the screen that you would have on your porch. Like you don't think of that as being flexible, but then, you have a 7-micron mesh where you can't even see the openings. That does feel like a fabric.
Oh, yeah. I mean, it can feel like silk.
But I think it depends on the application. So we're really going to talk about that. It's really a hard question to answer unless we know your application, what you're trying to do with it. In this particular question, they're dealing with larval aquaculture. They want to know if it's more rigid, like holding its place, or can it bend more like a cloth style material? And then we have to go into what sizes are you looking for so we can give you a little bit of a better idea of how that's going to perform. And we do offer really small samples. Sometimes they're too small to if you're trying to test an application, but if you're just trying to see the differences between mesh opening sizes, which is how ours is spec'd, you can look at that. But we also offer as little as 1/4 of a yard, and then up to you can get rolls of this stuff. So it can be with you in the R&D phase, and it can move with you through production because we just have so much of it. So there are lots of different ways that you can test just to make sure you're getting what you want. But again, that flexibility depends on both how you're defining flexibility, but also what size you're dealing
Right.
with. That's really going to impact that. Again, this is another one. Is it flexible or is it rigid? Can I get a small sample to review? Yes, you can. This one is about, it's a customer and they're wanting to use polyester mesh in a molecular biology application, and they want to autoclave it.
Oh, okay, yes.
So let's talk about that.
Yeah, the autoclave is, that's like always the big question.
It
right?
is,
You wanna
for mesh
sterilize something,
particularly.
And, if you're not careful, depending on your autoclave, depending on your settings, depending on your cycles, you can autoclave nylon and get away with it. But depending on your autoclave, depending on your settings, depending on your cycle times, you can wind up with a big mess.
Yeah, we don't recommend
no.
typically for, just because you can doesn't mean you should, right?
That's exactly right. Yeah, so generally that's where the polyester, if somebody wants to autoclave or needs to have it autoclaved, they need to stick with polyester.
Mm-hmm. Yeah. And okay, so this next question is dealing with is polyester screen mesh water repellent? So this is when we get into that hydrophobic versus hydrophilic conversation that we get to have pretty regularly. So sometimes you want it to absorb, sometimes you want it to repel.
Sure. Mm-hmm.
So what's your answer?
So
you hate me right now.
yes, true.
Okay.
This is, in its natural state, nylon is going to absorb the water. Polyester is going to repel water to a point.
But it's not technically hydrophobic.
It's not there. There's
request that by a special part.
I mean, I guess you could say technically because of the material properties. Yeah, but the reality is, in an application, and in many applications, its general properties will work for that.
Right.
There are other applications that require a coating. And this, I think, is important to understand. Let's say that we were working in an application that was a wet environment, and you were using this as a screen to protect some electronics, right?
Okay.
So you're trying to vent. And you don't want you want the ability for the those electronics produce heat. You want it to vent, but you really would rather water not get in with that. Then polyester is a good solution, but you might require a hydrophilic or a hydrophobic coating in order to achieve what you need for your application. So while it's a good starting point, there are other solutions that may make it a better product. So just to go out and say, oh yeah, that's the one to use, it is. But please understand, there may be other additional coatings or things like that you need to have for that application. Right. It's not just a one product fixes everything.
Right. And so, when you're dealing with, water, typically, our go-to is polyester. Doesn't mean you can't use nylon, but we just typically recommend that just for the sake of longevity. But then if it's really important, going to sit in there a long time, a reusable application, you might consider doing a hydrophobic coating. We can quote that. Let's see. What else do we have? Another aquaculture one. So we kind of already answered that question. Okay, talking about temperatures. So this is where the mesh synthetic fiber properties chart that we have on our website is really helpful if you're trying to compare the two based on characteristics. So we're going to deal with it based on the softening point and a melting point. So do you know the answer?
Do I know
which is better for higher
point?
No, not the
off the top of my head.
No, but which one holds up better in a higher temperature?
The polyester will hold up in a
great job.
Yes,
great job. So all of that's spelled out. We do anything from specific gravity to softening point, melting point, breaking points. All of those light and weather resistant. So you can have access to a chart in our resources center that compares those different materials and how they relate with those properties.
So I think one thing about the softening point that's interesting to bring up. This material, when it's woven, actually does go through a heat set process. I can talk today. So that process is obviously, you've had to heat it up more for polyester than you do for nylon. But when you look at the charts, the way it works is it goes through the weaving process, and then this heat set process sort of kind of locks everything in place, if you will. They're not melted together, so they're not hitting the melting point. They're getting close to the softening point in order to heat set that. It's important because that, knowing that going into it, like it's already hit that point. The material's not it hasn't degraded in any way, but it did reach that point. So you can kind of look at it and say, yes, it's called out, but you already have kind of the confidence of knowing, okay, no, it's already hit that. Gotten close to that point, in its manufacturing process. So there's a little bit of like knowing that going into it. If you're working in an application where you have that temperature requirements, there's some security knowing that that's part of the manufacturing process.
Great, yeah, that's good. Also in the same chat, we have someone who says, "Are you AI or are you actual HB?" Parentheses, human being. Oh. And we have Courtney is answering this one. I'm human. That cracks me up.
We're
yes.
RI, right? Like real intelligence.
Real intelligence. And then they go on to ask about buying swatches and samples. Again, a question that we get a lot. We don't do a lot of samples, and the reason is we don't have a minimum. You can buy 1/4 yard of mesh. For any of our other components, you can buy 1 stick of hypodermic tubing or wire. So generally the answer is no. Like I said, we have some little samples of mesh that we can give out if you're really in a desperate situation and even 1/4 yard seems unattainable. Another option though for you, if you are using mesh in a lot of different applications, we have these mesh lab kits, and we try to have those for many of the main categories that we use. And there are, I think, 6? How many are there? 9? 10? Wow. So many mesh lab kits. So we have all these kits, and they're divided into sections of sizes. So, of course, you can stock up on all of them and have access. But if you're working with a range of sizes, they come in these like 8.5 by 11 sheets, basically, and 2 sheets of each size. So you can look those up on the website. That's another way to sample out sizes without having to buy a large volume. So try and keep that in mind. So lots of questions.
They're stored in a binder.
They're stored in a binder. Really easy. Just stick them on your shelf. Yeah. Try to make that super easy. But that was the result of getting a lot of questions for samples and wanting to try lots of different sizes before committing. So that's kind of how we dealt with that. Hopefully that's helpful to you. You can just search lab kits on the website, and you can to get those to keep in your office, in your shop. Let me think. What's another one? We get a lot of questions about what size do I need if I'm trying to get this size to pass through. Do you have any advice on that?
That's...
I'm trying to be vague just because we're trying to answer that.
I mean, and you're starting off there. It really is kind of the right way to say is, okay, what do I want to stop? If we're talking about filtration, what size do I want to stop? At what point do I say, okay, I'm okay if something this big goes through, but if something this size comes along, I don't want it to go. Right. And that's the best place to look. And the best place to start in terms of like what size do I need? Right.
So you would want your pore size to be less than that thing.
Just slightly. And I mean, it doesn't, that actually, it can be a lot less depending on how much flow you need and because you're going to restrict
the various particles that are filtering through.
Right.
So again, we'll talk through you with that application, but you're looking for pore size, also known as mesh opening. That's how it's spec'd. So if you see like our part number, like the part number prefix is going to be like for nylon mesh is going to be UCMN. So that's our nylon mesh. And then there's going to be a dash 10 or a dash 120. And that 120, that 10, that's your pore size, your mesh opening size.
By microns, 120 microns.
In microns, yes. So that's usually the the key characteristic of the mesh that we supply. That's what people are mostly looking for. Then they might go into an open area percent, or they might go into a thread diameter. So there are these other characteristics, but typically the mesh opening one, because mesh is primarily used as a filtration or separation application material, that's the key characteristics. So when you're looking on the component supply website, we have those other characteristics in the charts where you're buying the product from. But there might be other questions that you have related to other applications. You might need a thickness for how you're going to lay that out in your device or in your application. So we can answer those questions too. We don't list everything. We try to list the critical specs, so we have access to those other characteristics. So just ask if you have a question about that. And then we do have a size chart that compares, so you can see the polyester and the nylon together and see kind of the differences between those things. So you can compare the physical characteristics and material characteristics. Let's see, anything else? And we're talk about color. An opaque white or a black are typically, we don't stock everything in the black. We have some specific sizes for that, but usually it is that opaque
So many
white
times the black really is an
color.
acoustical application.
Yeah. There's a question about, I'm using this to create an indwelling catheter for rodents. It's like more than I want to know. But does it come in contact with fluids, water, chemicals, those kinds of questions? So, we ask those questions and we try to get more details into, what the application is going to be coming into before we advise. But our kind of standard is you've got to test it. Like, we can't fully know your application or what you're exposing the product to. So, again, try using the lab kits, trying to test what it's going to go through, seeing how the material performs yourself, and always asking your quality information, your quality questions up front is so helpful, because sometimes you get into it and then you realize, I needed more information. So in the beginning stages, R&D, think ahead about the quality that you might encounter as your project progresses, and ask us in advance so we can make sure we give you all those answers as quickly as possible, because that can really slow you down if you decide or figure out, into your project that you need something quality that we don't necessarily provide, or might take time to test and figure out. I think that's all of that. Lots of flexibility ones. Autoclaving. I think we answered all the big ones that we get asked.
So I think one of you mentioned some of the quality. One thing I think you should go over is when somebody says, "Is it medical grade?" Like it's a medical application. And I mean, I think that's important for them to know what that process is. Yeah. Because it's going to happen.
So the various grades of mesh, you have kind of an industrial applications, which we've talked mostly about today, truly. Like even in medical device, there is an industrial application. So a lot of times that's what our standard off-the-shelf material is used for. Then you have a food grade. So this is used in like flour sifting, still industrial, but dealing with food particles, separation, sifting, things like that. And so we do offer and have on the shelf some food grade qualities. And this is, it's additional washes. And then you have a medical grade, which is again additional, it's essentially a cleaner mesh.
It's the same mesh.
It's the same mesh, same characteristics. It's just gone through these additional washes, and there are some additional quality-related standards that it will meet. So we can put some of those notes in the description of this podcast, so you can see that. The options might also be listed on the website, or you can ask a customer service rep. But it just depends on what you're using it for. We would special quote those. Those will never be stocked on the shelf, because they can be really specific and might need even additional things. But food grade and the industrial grade are options that we typically would have. But it is really based on the wash of the material, the extra washing processes that it goes through.
Which I think that's helpful, because if someone's doing some work in research and development, just because we don't, the mesh that we have on the shelf is, if you start off using that, it's a simple process to jump into a medical grade mesh. If you say, okay, now I've got the size that I need, I like it in my application, I like it in my device, I just needed to go through these medical grade requirements. Yeah. That is not you're not starting over, right?
Right, you're not starting over. I mean, essentially, the industrial mesh that we have on this shelf, or even the food grade, that's a great place to start with determining fit, form, and function for your application. Does this material work? Does it perform the way I need it to perform? And then when you need to get certifications involved, or you've moved into that next step, you can request the food grade, depending on the application, or the medical grade. And yes, the performance will be the same, but you'll have certifications that can accompany the product, which is beneficial.
Thank you.
You're welcome. So if you have any other questions or need other resources for that, please let us know. We're trying to make it really easy for you to determine what materials you need, give you great access to the specs that you have access to, and make it easy for you to go and change the world.